Thank you for joining us at Griffith Observatory for this live broadcast of the northernmost moon. The moon is doing something it hasn't done for about 18 years. It is rising and setting as far to the north and as far to the south it has ever seen. This happens every month over a period of about 2 years in a cycle that takes 18.61 years to complete. It's called the Major Lunar Standstill, and we're now about halfway through the standstill cycle. I'm Dr. Ed Krupp, Director of Griffith Observatory, and this charming and unusual astronomical event is part of a 2024-2025 campaign to follow the greatest monthly excursions of the moon. It is, in fact, brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. It also coincides with the birthday of Griffith Observatory Deputy Director Mark Pine. Happy birthday, Mr. Pine. Griffith Observatory cameras are now targeting this view of the San Gabriel Mountains on the northeast horizon from a point on the far west side of the observatory's front lawns. In a short time from now, the moon will rise on this line of light we've installed, and we'll catch it just about as far to the north as we ever see it. The moon is full tonight, and it will appear over the mountain at about 5:23 p.m. Pacific Standard Time. It is now early evening here in Los Angeles. The sky is getting dark, and the moonlight will be bright. The Griffith Observatory live stream broadcast team is prepared to catch that moonlight. The broadcast team includes Matthew Burlando, production engineer, Vanessa Alarcon, observatory astronomical observer, digital communications coordinator Pixie Iwata, production coordinator Ella Ritz, carpenter Grant Armstrong, and stage manager Michael Noble, and me. Well, we first broadcast the southernmost moonrise last June and July, and the most southern moon set, which dropped onto its line on Griffith Observatory's lower west terrace on last month, on the 18th, we broadcast the northernmost moonrise for the first time. The moon hasn't been rising and setting this far north since 2006. Its orbit is now tilted at the greatest angle outside the path of the sun. Those white disks represent the moon on its path, and the other circle is the sun's path. On the ground, this means over the next year, we'll see the most northern and southern moonrises and moonsets the moon ever reaches. Here again is our major standstill moonwatch view. The northernmost moon will appear on the line of lights installed on the front lawn. The greatest excursions of the moonset are marked with lines on Griffith Observatory's lower west terrace, along with lines for the solstice and equinox sunsets and for moonsets when the monthly excursion is least at minor standstill. The most northern and southern moonsets last happened in 2006, when the observatory was still under construction for renovation and expansion. The stone for the line had not yet been placed into the pavement. This is, in fact, the major standstill northern moonset on January 28, 2006. Between now and around December 2025, the moon will, each month, rise and set as far north and as far south as it ever can. And although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. The sun does something similar. In fact, it does it over the course of a year. In this illustration of sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it, and 6 months later in December, it rises at its southernmost limit on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and sunset seem to stand still, and the time when this happens is called the solstice, which means sun still. Griffith Observatory cameras are still targeting the northeast horizon, where the northernmost moon will soon rise. If we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon on the near side in this view. From there, they climb up the sky to their greatest height and then head back down to the western half of the horizon on the far side of the dome. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the North Celestial Pole, a spot directly above the Earth's North Pole. If that were all that moves, the sky would be simple. But other objects like the sun, moon, and planets also move around the sky on their own paths at different rates. Here we imagine the sky as a sphere with the Earth at the center. We can see the half of the sky overhead, but the other half is hidden by the Earth beneath our feet. The sun's path through the entire sky is called the ecliptic, and it's just a reflection of the Earth's orbital motion around the sun. The sun takes about 365 days, a year, to complete its circuit, and the tilt of the sun's path shifts the sunrise and sunset from north to south and back to north again. Each month, the moon circles the Earth in 27 days, and we see the moon's orbit shown here on that same sphere. The tilt of the moon's orbit guarantees the moonrise will migrate from north to south and back to north again in that time. So, the moon does in about a month what the sun does in a year. It moves from north to south and back again. But the moon does something else. The moon's monthly limits gradually change. Over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits and then back outside the sun's limits again. The moon set lines on the lower west terrace of Griffith Observatory make this obvious. The gray lines for the northern moon's inner and outer limits flank the gold summer solstice sunset line that points to the northwest. The gray lines for the moon's southern and inner and outer limits flank the gold winter solstice sunset line that points to southwest. When the moon rises and moon sets reach these limits, the limits don't seem to change much from month to month. These periods are the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. We are now in the season of major standstill, the time when the moon's monthly limits are far outside of the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. In another 9.3 years, the limits for the moonrises and moonsets will be inside these solstice points and will be at the minor standstill. The monthly limits then will gradually increase again, and in 2042, we'll have the next major standstill. So mark it on your calendar. Now, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun, and we can see that angle about 5 degrees in this diagram. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. And these edge-on views of the Earth, the sun, and the moon show how the moon's orbit flips from a greater angle to a smaller angle and back again with respect to the sun and sun's angle in the sky as seen from the Earth. Now, although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize the moon is doing this. And you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory tonight. Okay, we're still several steps ahead of the major standstill northern moon, which will show up soon. Despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins independently identified lunar standstill alignments in the Station Stones rectangle at Stonehenge. The rectangle enclosed the main circle of stones and was constructed earlier, perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions of Major Standstill southern moonrise and Major Standstill northern moonset. Here is the view to Major Standstill southern moonrise, and here is the Stonehenge Station's view to Major Standstill northern moonset. Hawkins also proposed sight lines between certain gaps in pairs of archways formed by the large sarsen stones erected perhaps 500 years later. This pair of openings accommodates the Major Standstill northern moonset. Stonehenge was not the first prehistoric monument assigned a major lunar standstill alignment, however. In 1908, British naval officer Boyle Somerville published a Major Standstill northern moonrise line for the Callanish stones, as seen here in Scotland's Outer Hebrides. In the 1980s, Gerald and Margaret Ponting instead favored an alignment shown here to the low southern moon. Here, that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric stone rings, and he identified Major Standstill southern alignments in the recumbent stone rings in northeast Scotland. The big recumbent stone on the moon's line operates like a stage across which the southern moon dances. This is the view to the southwest from the center of the Castle Fraser stone circle. Jack Eddy, a solar astronomer, spotlighted a 2,000-year-old Major Standstill northern moonrise alignment with the axis of the prehistoric Hopewell Circle and Octagon mounds at Newark, Ohio. Stephen Patricia reconstructs here Newark's Major Standstill northern moonrise. An ancestral Pueblo great house, about 1,000 years old, at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the Major Standstill northern moonrise, framed by the distinctive rock pillars in the middle distance of this view. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon last October, and Dr. Amanda Bosch of Lowell Observatory caught last December's full moon at Chimney Rock. The Griffith Observatory remote live stream internet broadcast team captured and transmitted worldwide the Major Standstill northern moonrise at Chimney Rock this past September and October, and is scheduled to return next September. Deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and through most of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We are about to witness the Major Standstill, northern moonrise, maybe another 5 minutes from the far west side of Griffith Observatory's front lawns, along a luminous moonrise line that's been installed across the lawns and is headed northeast to the San Gabriel Mountains. It also runs west of Mount Wilson, home of the celebrated Astronomical Observatory, and just east of Occidental Peak. It's well to remember, as Frank Sinatra said, the moon belongs to everyone. The best things in life are free. Thank you for joining Griffith Observatory's broadcast of 2024's last Major Standstill Northern Moonrise. The moon may be standing still, but Griffith Observatory never stops moving. We invite you to return to Griffith Observatory on January 13, Monday, when the moon will temporarily eclipse the planet Mars in a lunar occultation. And then on Thursday, January 16th, Griffith Observatory will present another installment of its monthly program about all space, that is, All Space Considered. Both events will be broadcast live on Griffith Observatory Television. Thank you.